Good morning, everyone. My name is Maxime Kouassi. I'm currently a master's student at Kitami Institute of Technology in Information and Communication Engineering. Kitami Institute of Technology is a graduate school of engineering located in Japan, precisely in Hokkaido Prefecture, the northern part of Japan. And I'm also project manager, IT project manager, and certified PMP project manager professional. Today, as part of this international conference, I'll be presenting my work. Note that as part of my master's program, I'm working on a research topic related to coffee science, especially focusing on espresso coffee extraction process. And today, my presentation title will be Causal Analysis of Matching Deviation on Espresso Sensory Quality. Here's the flow of my presentation. I'll be starting the presentation with a brief introduction and the background of the topic. And after that, we'll be moving on the methodology of my work. And yeah, so far I got some results that I will be presenting today. Of course, my research has some limitations that I'll also be discussing during this presentation. And finally, conclude my presentation with the future work. Now, let's talk about the background of the topic on my research. No, coffee is actually by far one of the most consumed beverage in the world. It's enjoyed for its quality, its flavor as well, and it also has a huge importance in the global economy today. But however, this field actually faces serious challenges related to global warming that threaten its sustainability. And when it's come to espresso coffee extraction process, we have several parameters that come into play. So, how to use those parameters in order to get the best outcome of the beverage itself. This is also one challenge. And so far, several research has been conducted to address those challenges, but still remaining some research gap that can integrate both the information from the machine regarding to the parameters of the coffee of the machine, and also integrate the feedback from the consumers in order to best understand what's going on, which parameters is related to each other in order to make a good decision for a model that can be a good fit for coffee consumers' preferences. So yeah, the motivation of this research is on 2 points. So as I said, we want to improve the quality of the outcome of the coffee. So how we can use those parameters, how we can use all these parameters to get the best outcome of the coffee, and also promote the sustainability. Coffee brewing process actually involve many resources such as water, electricity, and so on. So if, for example, let's say if you find a way to reduce the quantity of water that we use for the coffee, we can save an amount of water. We can also save some energy if we optimize those resources on the brewing process. So our goal is actually to use data science techniques and AI also method to optimize the extraction process of the coffee, and also finally be able to build a model, a AI model that can fit coffee consumers' preferences while having a sustainable impact on the environment. Now let's talk about the methodology of the work. So in this research, we are using this coffee machine, that is the Decent Espresso Machine DE1 Pro. So this machine is an intelligent machine that can record all the information about the coffee. When we make a shot of coffee, espresso, this machine can record all the information about that coffee. By information, I mean temperature, pressure, water flow, and so on. So we make the coffee with this machine, as I said, and this machine record all the information on the cloud. And after we make the coffee, we give the coffee to the consumer. And after drinking the coffee, they had to give us the feedback about the coffee they drink, what they do think about that coffee, and we collect all this information in the database. And after collecting all the information, we have to perform a separate analysis, the analysis of the information from the coffee consumer that we call subjective analysis, because this is subjective, and also uh, another analysis from the information from the coffee merchant that we call the objective analysis. So that's the information about the parameters that the machine has been using for to make the coffee. And after this separate analysis, you know, combine all this information and they perform another analysis, a deep analysis to understand what is going on, how the parameters are related to each other, and how they are influencing the final outcome of the coffee. And after understanding all of this mechanism, we will be able to build our AI model for coffee brewing method, for coffee brewing process that can fit coffee consumers' preferences while having a sustainable impact on the environment. So far I got some result in this research. So I will be presenting the result that I got. Before talking before talking about the result, let me introduce our data set. So in this research, we are not using any existing data sets because we are creating our own data sets. So we have two sources of data, as I just showed on the methodology. We have two sources of data. We have objective data and the subjective data. The objective data is from the machine, coffee machine, and the subjective data is uh, from customers. So far we collected 830 information from the machine and 151 feedback from the customers. So this gap between the sample size is because we started using the machine before we start the research. So the match we bought the machine a few months before the research, and we started research using it before we start our research. So this 830 information from the machine contains the information before and after the research as well. And yeah, to perform our analysis, we decided to match the feedback from the consumers with their coffee. So which feedback can be matched to corresponds to which information about the coffee. So when we did this one matching, we got 109 as sample size, 109 information, 109 feedback match with 109 coffee shots. So that's the sample size that we used for our analysis. So as I said, here we are using this matching, and here is how the information in the cloud looks like. We have this graph that shows the log of goal and actual values. So the goal is like the temperature, sorry, the parameters that we manually set in the margin. For example, when we take the temperature, we have to set the information on the margin, use this value to make the coffee, this value of the temperature to make the coffee. And when making the coffee, we have the actual value that is also recorded by the machine. So finally, we got two values for each parameters. We got two values for the temperature. We got the core temperature and the actual temperature. For the flow, we got the goal flow and the actual goal. So actual flow. So that's the information in the coffee machine. And here is the feedback from the customers. It's like a questionnaire. If you scan this QR code, you'll be able to see what kind of question we are asking to our customers during this research. So we asked them to rate the aroma, the bitterness, the concentration, the richness, and also give us the overall satisfaction on a score range from 1 to 5. And yeah, after we got all this information, we performed a correlation analysis, which was to help us to understand what's the interaction between the coffee features and the overall satisfaction of our customers. And here are the results when we perform the correlation analysis. So as we can see, the aroma, the concentration, and the richness are positively correlating with the overall satisfaction, while the bitterness negatively correlates with the overall satisfaction. And when you calculated the p-values, we show that the concentration, the correlation between the concentration and the overall satisfaction is not actually statistically significant because the p-value is above the threshold, which is 0.05. After the correlation analysis, we performed a causal analysis. So the causal analysis was actually to help us understand what is the effect of the parameters on the coffee features. So we wanted to see how inconsistencies in parameters can influence the final outcome of the coffee, the different features of the coffee. So to perform a correlation analysis, you need two entities, the treatments and the outcome. So as treatment, we choose the differences between parameters. If you remember, I just presented the information saved in the cloud of the coffee machine. We got the goal value and the actual value. So the difference here, for example, when you take the temperature, the mean different temperature is the difference between between the goal temperature and the actual temperature. And when we got this information, we calculated the mean of this difference for each parameters. So we wanted to see how the inconsistencies, how the deviation in those parameters can influence the features of the coffee. So for our analysis, we chose as treatments the mean difference on these parameters, and as outcome the bitterness and richness, I mean the features of the coffee beverage. Here is an overview of the causal task. So as you can see, based on what you want to do, or based on what you want to perform as task, you have to choose your model graph and then perform your task. And for Tsuyoshi task, we have several libraries in Python that can help us to perform this task. So here in this research, we used GUI library for this task, and GUI library actually here is presenting a simple diagram for causal task. So based on what you want to do, based on what you want to perform as task, you have to choose your graph model. The model is like the assumption that you want to verify during your research, during your work. And after modeling this assumption that you want to verify, you now have to identify the effects, and after identifying the effect, you have to estimate the effect. What is the value? What's the value of that effect? And after that, to refute this estimation. So the refutation is actually to check to see the robustness of your results. Can you result the refutation result will tell you whether you can rely on your result, on your estimation or not. So that's the causal actually the causal task, how it's performed. And yeah, so as I said, we have here our causal graph that we use in this research. We wanted to see whether or what is the effect of each deviation in the parameters on the different features of the coffee. And please note that in this research, we did not consider any confounders. So the confounders are the factors that can influence both the outcome and the treatments. And so in this work, we did not consider any confounders. And here are the results of our causal analysis. For example, when we take the mean diff temperature, the differences between temperature, we can see that the inconsistencies in temperature tend to decrease the aroma, the concentration, as well as the richness, and tend to, increase the bitterness in the coffee. So that's an example for the temperature. And when we take the other parameters, we can see that for the pressure, we have the inconsistencies in pressure, which is decreasing the aroma and the bitterness and increasing the concentration and the richness. And the inconsistencies in the flow is actually decreasing the aroma and increasing concentration, richness, and also the bitterness. So for our estimation calculation, we use the backdoor linear regression model for the as estimation method, because in DOI you have several methods for the estimation to estimate the effect. So in this work we use the backdoor linear regression method model. So the ATE here is the average treatment effect. So that's the effect that the outcome has, sorry, that the treatment has on the outcome. And when we performed our when we performed our estimation task, our causal task, we performed also the refutation, as we can see on the right side of the table. When we performed the refutation to see whether our results were strong or not, we found out that all the refutation gave us a good result. The refutation shows actually that the effect that we estimated are kind of exact. We could rely on that results. But the trick is that when we perform the p-value, when you calculated the p-value of the estimation, we show that unfortunately none of those value are statistically significant. So that was a trick of this work actually. And as I said, my work has some limitations. So now I'll be presenting the limitation that I constated, I found out during this work. And I guess you also, you guys also just saw some limitation in my work. And so as limitation I just presented, I got a lack of significance in some results. To rely on that result, I got some, results are not statistically significant. And for that, I suspected the small sample size of my data sets. As I show, I use only 109 as sample size in this research. Is For me it's quite few, but that's what we got for, as a starting point for our research. And also, as I presented in this research, I did not use all the factors that can influence the final outcome. So maybe in the future, I have to include, as much as possible factors that can be influencing the final outcome of the coffee, such as the bean type, the roasting level, the water quality, and so on. And also, I also plan to collect an important amount of data to perform a robust analysis to get a good result and to see whether that can, solve the problem or significance in the result, and also explore other causal estimation methods. So as future work, I actually plan to increase my sample size, collect as much as possible data. So please, you guys, if you can scan the QR code that I presented previously, you can participate in our survey, give us your feedback about your coffee and so on. So I plan actually to increase the sample size of for my research, and when I increase the sample size, I will actually perform a robust analysis using this huge data set. And after all the analysis and understanding what is going on, how the parameters are related to each other, how they influencing the features, how I will how they are influencing each other, I will be able to to make a good decision and build the AI model that can for coffee brewing method, for coffee brewing parameters that can fit coffee consumers preferences while having a sustainable impact on the environment. We Because as I said so far, we also want to also save some energy and also the water quantity for the brewing process actually. So yeah, thank you for your attention. That's all for my presentation, and please let's connect. And this is this QR code. You can scan this QR code and find my LinkedIn profile, my email address, as well as my mobile phone. So if you guys have any question, any recommendation, or even if you would like to collaborate in this research, please scan this QR code and then let's connect. Thank you again for your attention.